Okay. Hi guys. So we are going to start the editorial for start 2 to 10 and before ka last second problem. Let's assume make all. The question name is make all. One very simple input that is given to us is just n. Yes, n is given to us, and what we're expected to find is an array. Let's assume you have an array with you, which is an answer also. Yes. Let's assume you have an answer array which is of size 20 only. This is what you have to find. Yes, but how will you find this? Let's take an example. The input that is given to you, n, it can either be 20 or 50,000, some value. Yes, it can either be one of these two inputs. You have to find your answer array A such that whatever values are there between 1 to n range. Yes, let's call it I. What is I? Any value in range of 1 to n. If n is 20, you can pick I can be any value between 1 to 20. Let's say 16. So what you have to do, if your I is 16, you can pick a subset of your array A. What do you mean by subset? You can pick any number of values from the array, right? You can pick number of values from A to get sum as 16. Sum as 16. Yes. And what you can do, you can pick 10 elements at max from A. Yes, 10 elements at max from A. Let's assume if your array had value something like this 1, 2, 3, 4, 5, 6, 7, 8 up to 20, in case, yes, if this was the values you had, and if you have to generate a sum as 16, what we could have done, we have a couple of choices here. One choice is just take direct 16, which is also an answer. Is that right? Yes, just if you want not 16, let's assume if you want 20, just take direct 20. Yes, but this array would work if you just want for input n equal to 20 only, right? But if n is 50,000, yes, if n is 50,000, you cannot generate a value of 1,000 also as sum using these values because values are very small here. So question is, we have to generate this array and value something that decides such that we can achieve a sum of any value for any I between 1 to 20 and between 1 to 50,000 also. Yes. Now question boils down for us. We'll come to this part. Question boils down for us such that get 20 numbers to achieve sum of any number between 1 to 50,000. This is what the question has boiled down for us, is it right? We have to get 20 numbers such that using them we can generate sum of any number between these values. Yes, when we want to generate sum of any numbers, straightforward we should think of is powers of 2. Yes, because this makes sense, right? Because we know every number can actually be represented in a form of powers of 2, be it 5, be it 10, or be it anything. If I'm talking about 10 can be generated represented using 1010, which is nothing but 2 power 1 plus 2 power 4. Is it right? 2 power 3. Okay, sorry, it should be 2 power 3. My bad. 2 power 1 plus 2 power 3. That means any number can be represented using power of 2. But there is a small issue here. The issue is we want 20 numbers for sure. Is that right? We want 20 numbers for sure. But if you see, 2 power 16 ka value itself is this value, which is again greater than 10 power 5. Yes, that means only 16 numbers are able to get to the sum of 10 power 5. That means other 4 numbers we cannot even pick because they are anyway larger than 10 power 5. They will not be able to contribute to us. Yes, that means 2 powers will be a bad idea because it is leaving us a space of 4 more values which we cannot even fit here. 16 values are okay, but more than 16 we'll be getting numbers more than 10 power 5 here. Yes, that means we were at the good track, powers of 2, but this is failing because number of values are, for us we have only 16. Yes. Now when binary numbers are not working, there's a very simple thought that we want to expand our range, but value should be as minimum as possible. Is that right? That means if binary is not working, straightforward ternary should be our thought process where it should be going in. And what exactly you mean by ternary, guys? Ternary means powers of 3, kind of. Ternary is number system, but in vague way we say power of 3. And how do we represent a ternary number system? It is kind of like this: c into 3 power k. Yes, and we know c can be anything for 0, 1, and 2. This is what ternary number system is. There's nothing new here. Ternary number system means every single number x can be represented in this format. Every single number x can be represented in this format, where c can be any one of the value from this. Yes, let's take an example. How am I speaking this? If I want to represent, let's say number 2 guys. Yes, if I want to represent number 2, how can I represent this? I can simply say 2 into 3 power 0 will actually be 2. Is that right? Yes. If I have to represent 6, how will I represent 6? I can represent 6 like 2 into 3 power 1, which will be equal to 6. Is that right? Now can I represent 10 also? Think about it. Can I represent 10 also? Direct one term? No, but it is possible. How can it be possible? What is 3 square, guys? 3 square is 9. Is that right? So we can simply say c into, I'm dividing into 2 terms, c into 3 power k plus c into 3 power k. I can represent a number like this also, because we do the same in binary number system also. That means I can say 1 into 3 power 0 plus 1 into 3 power 2. What is our sum here? It is 10. That means every single number will be generated, can be represented using power of 3 also. Is that right? That means we just want initial 20 numbers of ternary and we are done with the problem. Yes. What is the conclusion here? Generate initial 20 numbers of ternary and we are done. And let's go with the proof, right? We have some idea that ternary might work. Let's check. I have all the ternary numbers here, please. These are all the initial ternary number system. Yes. Let's see if these could actually help us to achieve any sum or not. Let's say 100 I want to represent. Can I represent 100 using by picking any numbers from here? Let's start observing. Let's see. Can I represent 100 by the sum of any numbers here? This couple of choices we have. I can pick 81 plus I can pick 9, makes the sum as 90. I can pick 6, 3, 1, makes the sum as 100. Yes. Can I represent 10 also? 10 is even simpler. 9 plus 10, 9 plus 1 I can do. Can I represent 15 also? Can you check? Oh. Yes, I can simply say 9 plus 6, 15 is represented. Any number can be represented, you can check by yourself. Any number can be represented by these numbers only, is that right? And what is this? It is simply the term c into k power, c into 3 power k, that's it. Nothing more than that. Yes, and of course, we know c can be 0 or 1 or 2, is that right? It should be very clear for us. If you multiply anything with 0, value is 0. Yes, that means 0 is not even of any use for us, and as 0 is not even contributing. That means we only want these two values.